Hi, it's time for another math easy solution. We're going to discuss further into polar coordinates, and now go over example 6, and part 1 of it, go over part A or part 1, and it involves sketching a circle. It's pretty interesting, so let's jump right in there, and I'll solve part A in this part, and this video and next video I'll go over part B. So the example states, sketch the curve with polar equation r equals to 2 cosine theta. So let's do that, and in this one I'm just going to plot several points and then draw the curve, which it does in fact look like a circle. In fact it is, but I'll solve that in part B to make sure to find the exact equation to show that it is indeed a circle. But in this one, this is from my calculus book, so what it does is it plots points r theta for values of theta, which we know the exact trigonometric ratio. So we could do this by hand. So let's draw this in polar coordinates. I'm going to draw something that looks like this. And now the first point I want to find for this equation, so we have r equals to 2 cosine theta. So that's what we have. So let's pick one that we know the exact value. That's at theta is equal to 0. Recall that cosine 0 is just equal to 1. So this means that r is equal to 2 times 1, which just equals to 2. So in other words, we can combine this, and then we have the point r is 1. R is 2, not 1. R is 2, and then theta is 0. So in other words, if you graph this in polar coordinates, you would move to the right of this polar axis. This is 1. I'll draw this actually bigger. We'll go 1, and let's say 2 is over here. So yeah, just move things around a bit. So we have 1 there, and then this is the 2, and at this point the angle is, well, theta is equal to 0 here. It's just a flat line. So then we start off at this point. This is going to be at 2, 0. And now what I'll do is, well, I'll pick values that we know the exact trig ratios, and we could look at an angle. I'll split this up, or this is the 90 degrees from here to here. So what I'll do, I'll split that up into 3 sections, actually more than 3 sections, or 3 angles within it. So what I'm going to do is, I'm going to draw an angle like this. I'll draw this actually smaller, like this, and like this. And then this one here, I'll write this as theta is equal to, well, pi over 6. This corresponds to 30 degrees. The one in the middle, this is going to be here, theta is equal to pi over 4, or 45 degrees. And then all the way across here, this one's going to be, this is pi over 3, or 60 degrees. So yeah, recall that is 60 degrees. I'll explain this all in a bit further. So now let's look at the first one. So theta is equal to so at theta is equal to pi over 6 radians. So I'll be dealing in radians, but I'm gonna, this corresponds to, well, 30 degrees here. Because remember, if you add this up, 3 of these, 3 pi over 6 is just pi over 2, in other words 90 degrees. So we have this, and recall the easy way to memorize this, and I put a video description, I put the link in the description below on how to do this. We could draw, to see the exact trig ratios, so we could draw a square, actually not a square, I'm going to draw a perfect equilateral triangle where the sides are 2, 2, and you'll split this up into 2. So this is just a right angle, and this is 1, 1. So these are all the exact same lengths across everything, like that. So if we have that, then all the angles are the same, and if they're all the same, they have to add up to pi, or 180 degrees, and I'll put the proof for that in the video description below. So this is just going to be pi over 3. That is equal to 60 degrees in degrees. This is pi over 3 radians. This is going to be pi over 3, and this is going to be, well, pi over 3 as well. But we're going to split that in half, so pi over 6, and note, when you add up all these, pi over 3 plus pi over 3 plus pi over 3, this just equals to pi. In other words, this is basically 60 degrees plus 60 degrees plus 60 degrees equals to 180 degrees, and that is for a triangle like that. This is for an equilateral. For all triangles, all the angles together have to be 180, but it's all the same side, so we get that. So if we have this, and we know this length here, and this length is going to be, well, this is just going to be square root 3, and we could even calculate this out, yeah, by Pythagoras. So if we do square root 3 plus, square root 3 squared, plus 1 squared to the side squared, this just equals to, well, on this side is going to be 3 plus 1, this equals to 4. In other words, this equals to 4 just equal to 2 squared. So what we have is here, this is just Pythagoras theorem. So Pythagorean theorem, like that. Okay, so now that we have this, now we could find our trig ratio. So we want at theta is equal to pi over 6. That's over here, so recall cosine pi over 6, that just equals to, cosine is just adjacent over hypotenuse, so square root 3 over 2. So this equals to square root 3 over 2. So this means that r, which equals to 2 times cosine pi over 6, is equal to 2 times square root 3 over 2. This just equals to square root 3, like that. So in other words, combine these together, we have the point square root 3 and pi over 6. So that is one point like that. So we've already got this point here. I'll move this around here and box it. So we have this point, that's 2, 0. Now we go to square root 3. So square root 3 is less than 4. I mean, it's less than 2, because 2 squared is going to equal 4, and square root 3 squared, that just goes to 3. So basically, it's going to be moving up like this. If we draw a dashed line at this pi over 6 all the way across, we'll get a point something like this. It's not the scale. So at this point, this full length is going to be square root 3. So this is going to be square root 3 and pi over 6. So now the next point we could draw is pi over 4. But before we get to pi over 4, I'm going to do pi over 3 right away. It's easy to solve because it's just over here. So I'll do that here. So at pi over 3, this is, or at theta is equal to pi over 3. We get from above here, so adjacent over hypotenuse, 1 over 2. So that just equals to cosine theta, or cosine pi over 3, equals to 1 over 2. So this means that r, which equals to r equals to 2 times cosine pi over 3, that's 2 times 1 over 2, that just equals to, well, this 2 is cancelled, that just equals to 1. So we have the point 1 and pi over 3, like that. So we have another point. I'll draw this one after I draw the pi over 4, or the 45-degree angle. So I'll do this one next, so pi over 4, I guess just because it's before it. So at theta is equal to pi over 4, we could use the other method of doing this. This is just 45 degrees. If we draw a square with sides 1, 1, 1, 1, and this is just 90 degrees, or pi over 2 radians. Pi over 2 radians. Now if we split these are all the angles are going to be pi over 2. So if we split this up like that, what we get is here, this is going to be pi over 4. So we split this angle in half, like that. Here I just filled in the line, making it a solid line. So when we have that, so now using Pythagoras, this is 1 squared plus 2 squared, that's just going to be, well, 2. So then this point is square root 2. In other words, square root 2, square root 2 squared, this just equals to 2, which is the same thing as equaling to 1 squared, the side squared, add these up, that just equals to 1 plus 1 equals 2, like that. And here, just move things around, move the 2 there, deleted this one. So we have this one is by the Pythagorean theorem as well, PT. And I'll just put this in bracket, this is also PT, just to save some time in writing. So that's what we have there. So now what we could do is, well, let's find the trig ratios here. So cosine of pi over 4 is equal to, well, adjacent over hypotenuse, 1 over square root 2. And what I'll do here is I'm going to multiply the top and bottom by square root 2 just to simplify it. So the bottom becomes that just cancels, we get a 2, so we get square root 2 over 2. So this means, now when we add in our value here, r, that equals to 2 times, well, square root 2 over 2. That's just cosine pi over 4. The 2's cancel. This is equal to square root 2. So in other words, combine these, we have the point r is equal to square root 2, and then the angle is pi over 4, like that. So that's another point there, and I'm going to draw this all the way across. So we get this point, this goes all the way across here, but remember, it's just a right angle triangle. If this length is 1, then this length is 1. It's a height of 1 as well here. Here I just fixed that up. So at this point here, this is going to be distance of square root 2, and this is the angle pi over 4, like that. And if we just connect these, we get something that looks like, it's going to obviously look like a circle, as I've been explaining. And now with the point, this is the angle pi over 3, that is over here. So that's the point 1 and pi over 3. So it's a distance 1 across, so it's going to be, well, less than this, because the height is 1. So the distance from here to there, it's going to be 1. It's going to be something like this. Let's see, it's going to look something like this. Over, connect that here. And now I'm going to find out the angle at which, the angle or the point when we have the full angle across, which is, well, this is just pi over 2, or 90 degrees. So this is at pi over 2, 90 degrees, and we know this point out. That one is just easy to solve. So at the angle pi over 2, recall, or at theta is equal to pi over 2, recall that cosine pi over 2 is just equal to 0. So this is just, remember, this is a 90 degrees, so adjacent over hypotenuse, you just have a flat line like that. So adjacent is going to be 0 over hypotenuse 1, so we have 0 over 1. So that just goes to 0, so we have r is equal to 2 times 0, that just equals to 0. So we have the point 0 and pi over 2. So we have this point across, and now what we have is the point right over here, and this is at 0 and pi over 2. So then when we connect this point together all the way across, we get a circle. Let's draw this a bit better, like that. So it's something like a circle. And here I quickly move the point across because I believe it's supposed to be in line with this. I'll have to double check, but I believe that is the case. I just moved up to make it look a bit more accurate, like that. And now at this point again, I'll just write this one is at distance 1, and the angle is pi over 3. In other words, 60 degrees is pi over, that's 30 degrees, 45, and 60 degrees. And then going all the way to 90 degrees, we get this point there. And now the next thing we're going to do is, well, we're going to look at the negative version of these angles. So if we draw this like this and go here as negative pi over 6, and across here we get negative pi over 4, and likewise here negative pi over 3. So we just mirror this down, put a negative sign like that. And what we'll do is first graph the function of cosine to show you how it would look like, just to save some time. So we could do recall. Recall if we draw a cosine function like this. If this is theta, this is, let's get this y coordinate as cosine theta. Then what we have is the shape looks something like this, and then it just repeats itself onwards and over again. So it just goes something like this. But notice at this point, so this is the distance is going to be, well, 1. I'll just write this as 1, and then all the way at bottom here is at negative 1. So on this side here, this is from pi over 2, 0 to pi over 2. But if we go backwards to this point, which is at negative pi over 2, well, this is just the same exact points. We just get a mirror image. So I'll just draw this across, mirror image for cosine. So that's just a mirror. So if we have a point here at negative whatever, if this is, for example, pi over 4, if that's pi over 4, then we have the exact same value all the way across here. So we just go across it, whoops, and then this point here is just, well, negative pi over 4. And this exact same point across. So we just become a mirror image like that, so we can just save time and just write this down. Yeah, so we just have exact mirrors, so we could mirror every single one and flip it down. So we could flip this point down somewhere, let's see here, this point somewhere across here, and this one something across like this. It's just not the scale, and then here, and then the point across this one is going to be 0, well, 0, negative pi over 2. So we have the exact same r values because it's just a mirror image for the cosine. And then we could draw it out. So at this point, I'm going to draw this like that, etc., and it goes all the way down. So we get a circle. So this is a circle. Prove this in part B, so stay tuned for that, but it does look like a circle. In fact, it is. And at this point, I'm going to draw this dashed line all the way across here. It's a bit messy, but hopefully you get the point. This is going to be square root 3, and now we have negative pi over 6. And at this point, across all the way to here, this is going to be, the distance was, I believe, square root 2 and negative pi over 4. So square root 2 negative pi over 4. And now all the way to across here, this is going to be, this is just going to be 1 and negative pi over 3. Like that. Yeah, so that's the point. We just put a negative and we get a circle that looks like this. Yeah, now I want to make a note is basically note that I only graphed the points between negative pi, actually not negative pi over 2 and pi over 2. So I'll fix these up. Yeah, I just fixed that mistake up. So I only graphed them between negative pi over 2 and negative pi over 2. So from here to here, that's the only place I graphed the points. But these, draw this more accurate, just across here. Like that. Yeah, so from here to here is the only points I graphed. Yeah, but trig functions are periodic, and as you can see, it goes back and down, etc. But in this case, I only dealt with the positive r values, because we'll have positive cosine values in between here. But here, notice there's a negative here. But if we were to extend beyond negative pi over 2 and theta and negative pi and positive pi over 2, then we will fix that up. So then we will still obtain the same points because the trigonometric cosine function just repeats itself periodically. So it goes back and down, so we always go back to the same points. But for the values in which we get negative cosines, for example, in this one here we have negative, here we have negative, this just means that our distance r will be negative 2. For example, consider the angle theta equals to 3 pi over 4. Now this angle 3 pi over 4, that's the same thing as writing, well, 3 pi over 4 equals to, well, this is just the same thing as 2 pi plus pi over 4. In other words, we have 2 pi over 4 plus pi over 4. Just to show you, it looks like that pi over 4 is just pi over 2. So that's just pi over 2 plus pi over 4. So if we graph this here, that's pi over 2. So if we go extended by a pi over 4, let's say we get a point here. This is at pi over 4, so we get a point across here. So we're going to have a negative cosine theta value, and if we draw this across in our angle like this, and then we have, remember, this is going to be pi over 2. So this is pi over 2. We'll draw a right angle like that. Now if we extend it past by a pi over 4, so we extend past like that, that's going to be pi over 4. In other words, actually, pi over 4 is just half of it. So this one's actually directly in between. I'm going to make this a bit better. So yeah, just move that across the middle, and it should be somewhere around here to be a bit more accurate. So pi over 4 is exactly half. So then what this means is we're going to split this up like this, where this distance is pi over 4. So the total distance is the summation of the two. That's 3 pi over 4. But we get a negative r value. So if we, and also if we extend this, we get a, well, angle like that. This is distance 1. This is negative 1. And this angle across is as well pi over 4. Because this is just split these in together. So absolute value of that is just pi over 4. And yeah, this distance across, that's just square root 2. So the cosine of that is going to be, Yeah, so the cosine of 3 pi over 4 is going to be looking at this opposite, or I mean adjacent over hypotenuse, so we get negative 1 over square root 2, just as I've done above. So that's the value there. Multiply this by square root 2 over 2 like above. This cancels. We get a negative square root 2 over 2. The 2's cancel. And likewise, r, which r is equal to... r is equal to 2 times square root 2 over 2. There's a negative there. This just equals to the 2's cancel. We get negative square root 2. So what this means is we get a point, negative square root 2 and 3 pi over 4. And remember again, with negative distance values, we go to this angle pi over 4, 3 pi over 4, and then we just work backwards like that up to a point negative. So this is going to be negative square root 2 like that. And at this point across is going to be our negative square root 2 3 pi over 4. And in fact, so remember that's just pi over 4. This corresponds exactly to, well, this point here. Let me just see. So that corresponds to exactly this point. Because remember, this distance is negative pi over 4. But if you graph across like through here, and then through this line all the way across, dash it, this is just pi over 4. So yeah, we just work backwards. And this is the exact same point. So whenever it's negative cosine values, we just go work backwards, like negative distance r. That's for these ones, this one, but then we go back to the positive. So it just repeats itself over and over again. And yeah, that's all for today. Hopefully you caught this all together, followed along. It's pretty intense, but I just want to do this all by hand to show you. You can do this all by hand just to go in depth in its polar coordinates. And then basically every time you get the cosine, once you loop around, you go back and forth, etc., etc., and you just go around the circle infinite times. Anyway, that's all for today. Hope you learned, and yeah, thanks for watching, and stay tuned for another math easy solution. Also, you can download these notes and the link below. Thanks, and yeah, stay tuned for part B.